Hi, my name is Yalley. In this presentation, I'll be focusing on backward design and Bloom's taxonomy for learning objectives. So, what will you learn about in this presentation? First, the three stages of Wiggins and McTighe's understand by design framework. Secondly, I'll be focusing on the 6 levels of Bloom's taxonomy. The last part of this presentation will settle on an application of backward design and Bloom's taxonomy. So let's consider the first part of this presentation, the 3 stages of Wiggins and McTighe's understand by design framework. According to Wiggins and McTighe 2011, the understanding by design framework offers planning process and structure to guide curriculum assessment and instruction. That seems like a whole packed sentence or statement. But for effective teaching and learning to take place, educators believe there should be a proper planning and laid down structure of curriculum coupled with relevant assessment practices and tools that can build learners' competencies, and this can be only be achieved using informing instructional processes and materials relevant for today's learners. So in short, that is what Wiggins and McTighe's understand by design framework, also known as UBD, focuses on. Let's go ahead and explore these 3 stages. So the first stage of understand by design UBD focuses on identify desired results. That in the quest to plan effective instruction, we need to identify the desired result. What is the desired result that instructors want? This try to answer the time and content problem. The time and problem refers to the fact that we have a short time to cover a lot, and the content problem also refers to the fact that there is so much to cover. So, what do? We should be able to know and understand what we want students to know and what we want students to understand and what we want students to do. When we are able to settle on these 3 aspects of our instructions, then we can think about designing our instruction from that stage. For example, in a typical mathematics class or instruction, the teacher can identify desired result by a statement like draw a circle, label it, and relate the unique features of a circle to solve real world problems. That can be a desired result for a typical mathematics instruction. The second stage is determine assessment evidence. This tries to answer the evidence and competency problem. What will be the acceptable evidence and competency that learners have to show for us to really agree that they have gone through such an instruction? This try to also ask the question, what will we accept as evidence of student understanding and their ability to use or transfer their learning in new situations? A typical example in mathematics can be students can explain why they would prefer a round table or otherwise for a class discussion or meeting. The third stage is plan learning experiences and instruction. This tries to focus on the mediation, facilitator, and support problem. Educators continue to argue about whether a teacher is a mediator, a facilitator, or a support in the classroom. So at this stage, we try to answer the question, what activities, sequence, and resources are best suited to accomplish the intended goal for the instruction? In essence, a typical mathematics classroom can plan learning experiences and instruction by guiding students to explore the features of circular shapes, a circle with mathematical instrument like a compass, and also content specific technological tools like GeoGebra. In graphics, these three stages looks like this: identify result, to determine assessment evidence, to plan learning experiences and instruction. Good job. Now, we are going to focus on the 6 levels of Bloom's taxonomy. So, what is taxonomy of educational objectives? It is just a framework for classifying statements of what we expect or intend students to learn as a result of instruction. This is according to Crutwell 2002. So, when we talk about taxonomy, we are settling on specific statement that forms that framework, coupling the kind of expectation that instructors intend students to learn after the student have gone through that instruction. Let's look at what these six levels entails. So in essence, the 6 levels of Bloom's taxonomy present a hierarchy of events that learners goes through, especially for cognitive psychological development during instruction. So at the base of this hierarchy is remember. This is the stage that learners are able to retrieve relevant knowledge from long-term memory. Next to that is understand. This is where they are able to determine the meaning of instructional messages, including oral, written, and graphic communication. The next stage is they apply. This is where learners are able to carry out using a procedure in a given situation when they have gone through a specific instruction. The next stage is analyze. This is where learners are expected to break material into 8 constituent parts, detecting how the parts relate to one another and to an overall structure or purpose. The next level is to evaluate. This is where learners can make judgment based on criteria and standards. The final and the highest stage is the create stage. This is where learners are able to put elements together to form a novel, coherent whole or make an original product. We are going to see an example of how we can develop learners to achieve these cognitive levels during a classroom instruction. But we can focus on a typical geometry classroom where we introduce learners to shapes like triangles, square, circles, and at the very early stage of the lesson, we would like them to be able to remember at least the names of these shapes whenever they see them. At the next stage, we would like learners to also understand these shapes and their properties. So we try to let them know that a triangle has 3 sides, a square has 4 sides. The next stage, we would like learners to apply their acquired knowledge in the previous stage, but they can never apply without understanding what these shapes are and what their properties are. So that is how the sequence of this um, 6 levels of Bloom taxonomy works during instruction. Let's go ahead and look at a typical example infusing both Bloom's taxonomy and McTighe's, Wiggins and McTighe's 3 stages. So this application is a lesson or an instruction which is purposed to introduce the idea of circle geometry to learners. So these are learners who may or may not have prior knowledge of the idea of circles. So the objective is where we try to set the pace for the lesson and determine what we would like learners to know in this particular instruction. So in this objective, the first one, learners should be able to identify and label part of a circle. Secondly, they should be able to clarify the logic of circular shaped objects. And the third objective is for learners to calculate the area and circumference of a circle using the concept of pi. Then we go to the second stage, which is the assessment stage. Um, we are trying to use the backward design to go on onto the learning experiences, which is the last stage on the far right of this slide. So the assessment stage, for learners to identify and label part of a circle as an objective, we expect them to be able to identify and label part of a circle. The same way, for learners to clarify the logic of circular shaped objects, we expect them to be able to propose as an assessment and clarify with reason the best shape for everyday product. Okay, I'm going to explain that further. But let's look at the learning experiences. So I'll just take the first objective, the first assessment, and the first learning experience to illustrate this. So let's say our objective is to identify and label part of a circle. Then the assessment will be learners will have to identify and label part of a circle, which is like the circumference, the center, the radius, and all that. Then the learning experiences which the teacher need to carry out is to lead learners to investigate with mathematical instruments to explore part of the circle. This may involve learners drawing the circle with their mathematical instrument and locating where the center is and trying to draw a line from the circumference to reach the center to indicate the radius. These are the experiences that learners will go through. In the same way, if you look at the second objective, which is to clarify the logic of circular shaped objects, then in the assessment, learners will be expected to propose and clarify with reason the best shape for everyday products. For example, the learning experience, an instructor may ask learners to debate on objects and their shapes, and for instance ask them which one would they choose for a meeting, a round table or a square or a rectangular table, and then defend their reason. This is how we can infuse both backward design and Bloom's taxonomy for a typical mathematics instruction. So what are the key takeaways from this whole presentation? The first one is that both the Understand by Design framework and Bloom's taxonomy are good frameworks for assessment practices. Secondly, the UBD target intended learning outcomes, but Bloom's taxonomy present a hierarchical cognitive complexity. Okay, it presents cognitive achievement in hierarchy. Okay, and the last one, that the initial design of Understand by Design was to challenge traditional curriculum design. However, Bloom's taxonomy was originally designed for analyzing the demands of assessment items on university exams. I hope you've learned a lot, and I'm waiting for your feedback. These are my references. Thank you for watching.